the so in the process of getting to to the point where I'm at, I've make this full screen, click share, so there's a couple of things that I have sort of added to in the documentation. Step 18, which is test the steering control. Step 16, which is around installing the angle sensor. Step 7, which is around, flash the Teensy. And again, if you want to opine on these, cool. If not, I'm just sharing FYI to let you know that they're there. If I sort of work backwards on the test steering control, I label some assumptions here, and again, I think at some point you want to get all this up into like a GitHub kind of thing. I'm less familiar with that than just putting a Word document in, so to me it's more about just sort of capture the content that can be edited and massaged and place where you want to put it ultimately later. So just some assumptions. Because I'm using this, well, I just screen printed something that I had there, and that was an Arduino talking to this. Obviously, it's not an Arduino, it's Teensy. So not much there, because at the time that I was writing this, I couldn't get it to talk. So I need to go back and clean this up. But I do have in the Teensy firmware, these two examples. So the first example, and I can't pull it up because I don't think Google has a, well, let's see, what would I do? Open with, will that work? Nope, that doesn't work. If I download that, and then, I mean, this is just, again, from a testing perspective, just a simple test to publish. I went so far as to make it a publisher, remind myself how to make a publisher. So this was just a simple test. I'll add that to the instructions. Hey, you install your angle sensor and run this test just to make sure that you can get access to your angle sensor. Working out that was a challenge for me. I couldn't figure out what standard message data type I needed in order to actually talk to this particular sensor, but I digress. I did get that finally worked out. And then, from a test the angle process, getting back to the step, so wire the thing up, run the publisher test, then you're good to talk to it. Then, for me anyway, the process was just to set, to manually move the steering left or right, run this program, and it would bring it back straight. I thought that was a safer way to do testing. I mean, the next test, although I have not written the code, the next test would be, give it 3 or 4 or 5 positions and just have it cycle through those positions, but I haven't written that code. It would obviously be based on this. This is basically saying, hey, 1233 is straight ahead, and you know that because the previous publisher, you move the wheels around and you're able to see what it's actually sending as the signal. And then this effectively just brings it back to straight. And I had to do a filter here because this thing is periodically sending a high value. I think there's some idiosyncrasies of I2C communication. For whatever reason, it's periodically sending a high value, and that sort of freaks this out. So this very crude filter is in there to try to clear that out. Anyway, that's the state of the nation on having a couple of test programs. Back to some instructions. This was step 16. I was obviously very clear that this is based on my approach to installing an angle sensor, which is different than yours, and that's quite honestly I'm not sure is robust enough to be useful in production, but certainly is useful enough for testing. So some notes about connecting the I2Cs, some notes about the board, some notes about which pins to use. The Teensy actually has 3 different I2C setups. I put some notes in here about soldering the Teensy to a proto board, doing a desk check, connecting it back to the production unit, and then sort of 3 layers of testing. One just to talk to, hey, I can talk to the Teensy, I haven't broken anything. Second, to do this chatter file, which is a very basic piece of code on the Teensy that just sends a message back through, it was node handler, or it actually produced a topic. Looks like, yeah, it produced a topic. So it produced a topic called chatter. And then finally, actually reading something off the AS5600. Yeah, this is an example of where it was still high value, so I need to go back and clean that up now that I got that to work. So anyway, that's the state of the nation on having actually done the testing and following up with a documentation path. For me, if I pull up the milestone sheet, and I've just tried to keep track of some of the detail things that I've been working on here. Blue means complete, yellow means not complete. I've got to mount the Citron motor controller in Teensy someplace, and so my next step is to physically get that mounted. I also was looking at making another rotation sensor at the front axle. Not sure how that's going to work out or not, but if putting it where I've mounted it doesn't, I get too much vibration or something, I've as well got a secondary thought about mounting something on the front axle. So that's where your Pennsylvania, staff is at.
That's a lot of progress there, Al.
Hey, Jeff.
All right.
Do I still have sharing on? I never know. It looks like I've lost sharing.
I can still see it.
Okay, good. I lose my buttons here, I think, on my meeting controls. I have 3 screens, and my meeting controls seems to go somewhere. Anyway, so that's what's going on in my world. Going. Not sure why I can't get back to the meeting control deal.
I've noticed a little bit, put it as a little tiny picture on your screen on your desktop somewhere, so you got to go find that and you just hit the enlarge button there to get it back. Because I keep losing that stuff too and can't usually figure it out.
Yeah, probably because I have 3 monitors going. Anyway, Jeff, what's going on in your world? And I'll continue to work on stop screen sharing.
Well, I'm back to fighting with Novotel again, and that's not making me at all happy. So they wanted us to change our authorization codes, and then they gave us one, and they sent another one and said, oh, that was the wrong one, put a different one in, and then you got to turn it on and put it outside and wait for the satellite to send you some kind of update stuff. And none of that seems to be going well. I don't think they know exactly what they're doing is one of the problems. And I did what they told me to do it, and it didn't seem to fix it. So then on the way home, they said, well, the one guy keeps saying, oh, it'll come out once an hour. So I put it out there, and after like 6 hours, I say, well, I'm going to go home. So I took it off my roof and put it on my hood so it didn't blow off while I was driving home. And as I was driving out, I noticed that there's a green light. There's an LED on the side of it that tells you whether it's got a PPP fix or it's PPP converging or a single point or something else. And I got like 2 blocks away, and I noticed that the green light, it started blinking, which means that it, for some reason, dropped back to a lower version. And by the time I had time to think about it, it dropped to yellow, which meant it dropped to a single point fix. And the only thing I can think of, there were some trees in the corner as I got ready to turn the corner by the stop sign, and that's the only thing that should have blocked anything. So anyway, I thought, that's interesting. So I went a couple blocks and pulled in and hooked my laptop up to it. And of course, my laptop won't connect because for some reason their crappy software doesn't want to work occasionally. And so you have to go through I got 3 separate COM ports I can hook it up to, and I have to try each one. And by the time I got the thing connected again, it went back to green again, so I didn't know what was happening. But then as I was driving home, I kept watching it. And a couple places, there was like a couple of places have railroad tracks going over the top of the road. And I noticed a couple of times it was dropping out. So the very last one of those I came to, I watched it as I got there. And just as soon as I got to going under this underpass, it's only like 20 or 30 feet wide or so. Just as I entered that, the green started flashing. And I thought, oh, that's interesting, what it's going to do. By the time I was exiting, it had dropped back to yellow, meaning it had a single point fix, and it might have dropped out completely. And then being PPP, it takes a while to come back. So I'm now trying to figure out how I can set up a log file and go drive around today and find out what it's doing, because that really doesn't seem, to me, that doesn't seem acceptable. But so at that point, you would probably have to have something that says if it drops out, you're now running on the IMU, and you have to keep that going for 10 seconds to 60 seconds or whatever until it gives you a signal back, and then it's not even the best signal you can get. And the other thing I noticed that driving around, it looks like they just report a standard deviation that says this is how good we think the fix is. And if you're setting in a static condition running this kind of correction, it says it's like 1 to 2 centimeters. And I notice when I'm driving, it's worse than that. It's like 10 times worse. It's like at least was it 10 centimeters? Yeah, like 10 centimeters basically as you're driving. And it could be that's just a characteristic of this whole GPS thing, that if you're static, it gives you it thinks you got a better position, and once you start moving, it could be that just drops back anyway. So that's where I'm at with the Novotel stuff, and I say I'm not real happy with them or their company or their crappy software or anything else. So the other thing I did last night was I sat down and started playing with my PWM board. I pulled out my oscilloscope, and the first thing I did was I pulled out that little servo controller box that's got the pod on it. So I hooked that up and put the scope on it. And one thing I wanted to verify what that was putting out for a PWM frequency. And the thing I wrote it on doesn't appear to be here. Let me look in my laptop bag again. Here it is. Let's see. So that box is running at a 50 hertz rate that it's putting out. And then you can see as you move the knob back and forth, you can see the PWM changing. And I was planning on going to 60 hertz because I thought people either ran it at 50 or 60 hertz. But the more I look, everybody says, no, they run it at 50 hertz. So that gives me a little more clue as to what's going on there. And so then I ran the wheel over to one side, and somewhere I was playing with this and I realized, well, my linkage needs adjusted. So I loosened up my linkage rods and recentered some stuff, and it works better now. I can get pretty much the full travel without it banging into anything right at the moment. So then once I got that done, I ran it over to one side, and I think at one side is 1.42 milliseconds and the other side is 1.88 milliseconds. So it gives me a indication of what the numbers have to be. Just turning the knob there, I could see what numbers have to come up. So then I moved on to the PWM board and my software, and they claim that comes up as a default of 200 hertz if you don't do any changes to it. So you power it up, and that's the frequency it runs at. I put the scope on, and it was running like 203 or 202 hertz or something like that. So that was pretty close to what that was. And the other reason I needed that was because in order to change that, you got to go change some numbers and write to some registers. And I wanted to verify, while I had my scope out, if I could actually do that. And I was able to set it to either 60 hertz or 100 hertz or 200 hertz without too much trouble. It's just a matter of calculating the number and punching it in. And then I thought, well, one of the things I'm going to do, I need to verify that if I know it needs to be 1.42 milliseconds. So I calculated that, how many counts that was going to be, and punched that in and looked at it on the scope, and sure enough, it was right on where it was supposed to be. So I did it for the 1.88 milliseconds, and that one was right on also. So I now know how to calculate that. And what was the other thing I was going to do on that? Oh, so the other thing I noticed was if I run that PWM board at 60 hertz, and to get those two numbers that I need, I only get like 113 counts between full left to full right, which without actually trying this, I can't visualize if that, if 100 positions for my full steering is good enough or not. And then if I speed it up to say 100 hertz, so the ratio of the pulse to the total, the pulse takes up more time. So basically at 100 hertz, I get like 190 counts. So it's not quite twice. It's like 75% more than what I had before. And then if I run it up to 200 hertz, I get 382 counts. And it turns out between 100 hertz and 200 hertz is exactly a double, because it's just a doubling of frequency. And I kept thinking, well, without trying it, I'm not sure that's going to be good enough. So I pulled up the data sheet for my microcontroller, and it's got a 16-bit timer on it. Al, your screen sharing just went away. You must have figured it out.
Well, when Matt made his post, then the thing popped up. I don't know why that is. So I was able to press stop share.
Oh, okay. So I moved on the microcontroller. It's got a 16-bit timer and a 48 megahertz oscillator. So I figured out the numbers on that. If I divide that down, I put the right prescaler, I can get 60. It comes out 61 hertz. And at that point, I get 1,800 counts. So then that's, it turns out it's 16 times more, because the timer is 16 times as big on the microcontroller. So it could be I'll just drop back to the microcontroller to run the servo and just use the PWM board to run my LEDs. I think it'll probably work out better that way. So, but at this point, I just move a wire back and forth, plug into one or the other, and then run whichever software I want. So it should be fairly easy to test all that.
So you're doing this to control that super servo?
Right.
So isn't the Teensy output at like 20 hertz?
You say, does it?
Yeah, I don't remember, because you were mentioning that your control board is outputting at 50 hertz.
Well, the control board's that little thing I bought on eBay. That's the little box with a knob on it that you turn, and that puts out 50 hertz.
Okay.
And I don't know what the Teensy puts out because I'm not using a Teensy. I'm using the PWM board, just a little I2C chip, and the microcontroller is that ST Micro STM32F for Discovery board, I think is what they call it.
Okay.
And
What happens if you are outputting at too low of a frequency?
everybody, because I went out and looked because I wanted to know the answer to the fact if I run it too fast, what's it going to do? And I got lots of people with lots of opinions, and everybody thought they were experts, and they kept saying, "Oh, but if you run that 50 hertz is the lowest you can run," because, and everybody kept saying, "If you want to see, just try it." So I think what happens, it starts to stutter and does stupid
Okay.
things if you run it slower than 50 hertz, and everybody kept saying, well, why would you want to run it faster than 50? That's the standard. And well, like me, they wanted to run it faster for either because that's either they think it'll give them better resolution, or somebody's saying if you run it faster, you get better torque out of the thing. And
Okay.
basically they were saying that the original servos had some kind of a pulse stretcher. So it took the 50 hertz in and they would expand that out to make a bigger pulse to run the motor. And it could be that kind. You can't really speed those up too much or it's going to, just screw up the way it works. And that's, I don't know if they still work the same way. One of the experts seem to think that they still work the same way as they did 50 years ago. So I don't know that for a fact. But I'm thinking like on the super servo, it's probably just got a microcontroller and it's just measuring the incoming pulse width. And then based on that, then it runs the motor on any way it wants to. So I'm thinking it's probably not going to care how fast I run it. So whether I run it slow or fast, it's probably going to work okay on that. But I haven't plugged any servos into any of this stuff yet to see how they act. And let's see, what was the other thing? So as I said, there was lots of experts on there, and they say, oh, what's the inductance of your motor and the blah, blah, blah. And somebody else says, well, it has nothing to do with that. The incoming pulse isn't directly driving the motor. So there was lots of discussion going back and forth, but I never did find an actual answer on that. So, but I'm thinking at this point, if I go to the actual microcontroller board and run it at say 50 or 60 hertz, it should give me plenty of resolution to run the whole thing. So I think I'll be okay on that. And I was going to show you on this. So on this one, this is one of the tools that comes with that microcontroller board, and you pull it up and it shows you the picture of the chip, and then over here you select your peripherals on the side. So the one that right now is connected to there's 4 LEDs on the board that are connected right here. Are these labeled? No, they're not actually labeled, but if you look at the schematic, there's timer 4. There's 4 pins there that are tied to LEDs, and I think this is the 4th one that I'm using that as a GPIO or something. Or no, this one here. It says GPIO output. So technically, all those could be PWM outputs on timer 4. And then when you go to configure it, you pull up the configuration tab, and you say timer 4, which I already have initialized. So on here, I had it set up where it says it takes the 48 megahertz clock and divides it by 2400. It was actually setting a length of 2400 counts out of 65,000. So if I set this back to 0, I think is what I got to put that. Either 0 or 65, 536, whichever number goes in there. And set my prescaler here. I think I decided to set a prescale of 12. Then when it divides 48 megahertz by 65,536 divided by 12, I think comes out to my 61 hertz that I need. So basically that sets up the timer. And then down here, it's got the multiple, here's the 3 channels that are set up for PWM. So basically that's all you have to do to initialize it. And then in the code, when it's running, all I got to do is just right here it's right into those 3 LEDs, and you just say the timer, and the CCR is some kind of, that's the something control register. Oh, right there. TIM capture compare registers, what that is. So basically you just write a number to that, and it just sets the PWM, and away you go. And what I was doing for my PWM board, I just got a function somewhere that says, take the value I sent it here, here's the channel. So it picks the channel inside the register, and then it takes this value and just writes out as 2 bytes to the thing. So I just have a function here to set the number on each channel here to do that. So either way is going to be fairly easy to do. It's just a matter of picking a method, and as I say, I think for the servo, I'm going to go with the with this method up here. Just use the existing timer. It's just that all the once you set the prescaler and the frequency on a channel, all the timers on that channel or all the PWM channels are going to run at that frequency. So whatever I set these at, so if I'm still got my LEDs on there, they'll just be running at the same frequency, which they don't really care what the frequency is. So anyway, that's how far I got with it last night, and now it's just a matter of getting hook a servo up to it and see how that's going to act. And I've got some of the micro servos and standard servos and some big servos, and I got the super servos, so I can try it on various different ones to see if any of them act differently. But I'm guessing almost all of them are going to act the same except for the super servos. It's got a built-in microcontroller. So that's how far I got with that. And no, I can't. Oh, I lost my screen again. Oh, wow, I lost my screen. Oh, man. Let's see, is it back here? Oh, there it is. Oh, so I found on the right there, I've got the little pictures of people, and then right at the top, there's a thing I can say, enlarge it. That didn't do it. No, that didn't do anything. So no, I'm screwed. I can't figure out how to get. Oh, there it is. The stop shares at the top. Okay, never mind. Okay. So that's what I've been up to. Oh, one other thing I'll mention. If anybody's looking to buy yet another F9 U-Blox F9 receiver, they now have a special where you can get the F9 receiver and the Novatel multi-band antenna for €199, which is like $20 more. So basically you're paying $20 for that $60 antenna. If anybody's looking to get that one, I don't know of anybody yet that's actually used one of those antennas and can say they've compared that to some other antenna. But that's the one that U-Blox made to go with these boards. And so I don't know how well it's going to work, compared to say the survey grade antennas or even those ones that RDU Simple is selling. I guess they did put one little chart. If you go look at their webpage, there's a chart that says here's the one we're selling, and here's the U-Blox multiband, and here's like a Talisman antenna or something. And their conclusion was they all worked about the same. They said basically if you take the labels off, you wouldn't be able to tell which is which by looking at the numbers. So I don't know. I don't know how well that works.
Do you happen to have that URL handy, Jeff?
I can go look it up. I noticed they've got another. If you go look at their blog or look at their what do they call it? Under support forums, under the tutorials under support, they now have what they call Hack 1, Hack 2, and Hack 3. And Hack number 1, they're telling you how to get data into your device over that. There's an extra little USB port on there, and it goes through an FDDI chip, and it's supposed to be to reprogram your radio. Here, let me type this out. I can't do two things at once. I can, but I make a real mess if I do that.
While he's doing that, Matt, do you recall what frequency are you using for the Super Servo on the transmission control?
I have no idea what Jeff was talking about. I just sent out a PWM command and it worked. I have no idea.
So I just posted that link there. That's the. Someone posted something too. That was the basic starter kit. So this page I posted there said, oh, by the way, this is the way we're putting a different antenna on with the starter kit, and it's. Oh, wait a minute. Wait. What's going on, dude? What happened here? From me to Droder privately. Oh, that's not what I wanted to do.
Yeah, click everyone.
I see something from Soen to everyone.
I'll have to retype all this again. Okay.
No, you copy and paste it. I can copy and paste it over.
Simple.
That little antenna, they're saying that, Soen, you posted the €199 deal, RTK2B basic starter kit. That little antenna is as good as the white clunky quote-unquote survey grade antenna?
What I decided was the one that came with the Ardu Simple. I got the one that didn't have the plastic cover on because again they screwed me, saying they're gonna hold my order to the last if I got the newer one. And then they held my order to the last. But anyway, I compared that one to my white one, and the white one seems to work better. And the most extensive testing I did, it was laying on my living room floor, and I hooked them both up, and the white one is giving me better signal strength. So I haven't really compared them to see, if I'm driving around or whatever, how well they work. And I haven't even put them both outside and tested them to try that. So I don't know. I'd like to find somebody that's got, several different antennas so they can say, this one works, this one doesn't, or it's really worth spending the extra money. And they want to charge you, like $90 for that little antenna. And I think SparkFun has it for $62 or $63, and DigiKey wants it for like $63 or something for that new U-Blocks antenna. So depending who you buy it from, there's not really a whole big price difference on that, because if you buy the one from Ardu Simple, and basically it's the same price as the China one. You can't buy it from China now because now Trump just said everything from China has a 25% tariff. So we're not going to have to ride all this out until people wise up and either overthrow the government or slap somebody upside the head or whatever. So I guess
don't use that overthrow term. It'll trigger the NSA to break on our line. And
well, that was my choice of words. That's not what I was going to say, but I quickly backed off to that one. So so the bottom line is, I don't know.
Somebody had produced a comparison between, I thought, this black U-Blocks antenna and something else. Where did you see that?
That was on that Ardu Simple website. Mm. Let's see. If you dig through their tutorials and stuff, they got various just cute little stories of nothing else. Oh, back to the things about the hack. So hack number one was how to use this extra USB port on there so you can push correction data into your chip. So if you don't want to use the radio, you could do it that way. And then their hack number two, they're saying, well, if you brick your device, here's how you can recover it by putting some jumper wires on, and then they're connecting that FTDI chip on there to the UART1, so you can talk to it that way. So that's one way to get, if you wanted to run your UART1 and get both bidirectional in and out of the thing, you could do that. Because the hack number one seems to be just one direction. I had to look at it for quite a while to see what they did. They blatantly tied the transmit and receive lines together, but then you have to go into the F9 chip and say turn off the transmit for UART2, but turn on the reception for the correction data. And the more I looked at it, so basically they tied all the wires together, and that apparently works, because when you're receiving data over the FTDI, it's what's driving the bus and everybody's happy. But you can't, it's not bidirectional by doing that. And I wanted to make it bidirectional, but that's going to require a razor blade and soldering some wires. And they didn't leave any pads to solder onto, so you're probably better off, if you want to do that, use the UART1 and then wire it into that chip. And if you want to, you can also use UART2 through the Arduino pins. So there's lots of different options there, but they just didn't give it enough thought when they made it to keep me happy anyway. So I probably wouldn't been better off with the either the SparkFun board, because they didn't add that extra stuff on, so you don't have stuff in your way. And then Drotech has one now for around the same price everybody else is selling it for. It's a fairly clean looking design that I think just has one connector with lots of pins on it. And then that CSG shop, which I'm not, I really shouldn't recommend that. That's where I got my M8T receivers from, but that guy gives you absolutely no support, because even if you order something, say, what size battery do we put in this? He won't even answer that. So. And then somebody else was complaining they were trying to order the F9 receivers and they didn't get it, and he wouldn't respond to them. But now that there's a good supply of them, maybe you can get them through there. But so I won't recommend that place, even though everything went just fine. They're in Latvia, I think is where they're at. But you just go to the internet and you say, here's my money, and 2 or 3 weeks later it shows up. And so as long as you don't need support. So there's various different models out there that you have to look at them and say, what kind of connectors do they have and what do you want to hook it up to? But at this point, I've got 2 of the Ardu Simple boards, and after I bought that, I thought, well, maybe I should have got the SparkFun one because it's a little more flexible, but I didn't. So that's kind of where I'm at right now.
That's a whirlwind.
Oh, and then back to the hacks again. Then they've got hack number 3, and that one again. If you brick your device, they're showing you how to. There's a pin on there called Safe Boot or something. So they're showing you how to hook a jumper up to that to reload it. So this stuff's slowly coming out. You know, once people screw up their boards, you say, well, here's how you can fix it. So they post it on there so you can see what they're doing. I think that's under the tutorials where they have those. And there's just a few other tutorials telling you how to set the thing up, and then some of the older stuff was all, maybe it was on the blog is where I actually saw that. I think the blog tells about it, and then the tutorials where they actually list the data. And if you dig through the forums, they've got lots of people asking how to do things, and sometimes you get decent answers and sometimes you don't. So, but if you play with these boards, that's where you want to dig through, is see what they got.
I'm looking at the Drotech website. So the F9P is what they put on their board. Is that the same as the Arduino Simple?
Yes.
So they're showing €199 without an antenna.
And on a related note, when I was watching that Ag Open GPS meeting, the guy Farmer Brian Tischler, I think is his name. He's in touch with these people at the Arduino Simple place, and he's saying, you know, you should put 2 of those on a board so we can do a dual antenna and get the heading out. And he says they were actively thinking about that, and I just saw something either posted or saw some kind of an interview somewhere, and they say, yeah, we're working on something where we're going to put 2 of these on there, and then on the Brian Tischler was saying that they're actually going to put 2 of them on there and generate a custom message for the Ag Open GPS people. So whatever they want coming out of this thing. So if they want, say, latitude, longitude, and heading, which is the heading from the dual antenna, you know, they're going to create a custom message to do that. So assuming it's going to be 2 receivers and some kind of processor on that board that can get the data and send it out. So that's apparently something they're working on. Oh, I think it was on the Arduino Simple website. I saw it because they were saying that we're working on this, and I thought, well, I hope they put it out so somebody can say, don't do it like this, so I don't have to take a razor blade and hack your board up when you're done. But I didn't pursue that, so we'll just have to see what they come up with. I don't think they had any prices either, but Brian was saying, yeah, if you can get it for under $500, that'd be great. I think, well, you know, it'd be better if it's $200, but well, we'll see what it comes out, what they come up with. So, Matt, how's your experiments with your heading and GPS receivers coming?
Well, I looked into that and I got lost a little bit. Having the dual receivers, I think, would be nice. I just got lost on how to set up the moving baseline and then how to send in corrections over. Like from the Raspberry Pi, if you have them connected to the Raspberry Pi, how would you send corrections out? There's a lot of configurations in there.
And I'm thinking as far as how you do that, basically it puts out messages on a port, and if you want, you can put messages in on the same port, and I think you can mix all this stuff. So as long as it's, say, hooked to the Raspberry Pi, you should be able to have it sending you the position data, and you should be able to shove correction data back over that same port. And I think I think you can mix messages too. So so if you're sending it, I can't even think what else you would send it, but if your Raspberry Pi is sending something to the board and saying, here's some information for you, plus sends the correction data at the same time, I think it sorts all that stuff out and works. And what I was just planning to do, since it's got multiple ports, it's got the USB and then the 2 UARTs, I was just going to feed correction data in on one of the UARTs, and then for the moving baseline, use the second set of UARTs to wire the 2 boards together, and then use, say, the USB port to get the data back out for like a ROS driver or whatever. So something else I thought of, and I was doing it with my M8T receivers. If you could put both receivers on your on your lawnmower and say, just run an RTK mode, say this one's the base, this one's the rover, and you're not going to get the correction data into it, but it should give you your heading out, or it should generate a heading, but I don't know what message that would show up on if you can, easily get that out, because I that might come out. That might come out on your whatever the normal NEMA messages are that say here's your heading. I don't know if that is active if you're not moving. Since it's an RTK mode, that might work. So I'm not sure, but anyway, that might be another option. Just put it in RTK mode, and not do all this other monkeying around, and then later you can figure out how to get the moving baseline to work.
So I tried putting one GPS as the stationary. I tried doing like pedestrian and vehicle and then stationary. And then I had the other GPS. And then I had two ROS drivers grabbing the position data, the NEMA stream. And then I would do the calculation in a ROS node to figure out heading. And I didn't really get that, feel good about that.
Well, I'm just thinking in RTK mode, somewhere like if you run RTK Lib, one of the things they say is, here's your baseline, and it says here's the length of your baseline, and here's the heading of your baseline. They don't output that anywhere, but that's a concept that exists internally. So it could be that if that data exists on the rover of that pair, it says here's the length of your baseline, here's the heading. If you can just get that message out, I think maybe that just is the number that you need. But there's hundreds of messages, and I'm not sure which one to use. So, and
Yeah.
Sometimes they're active under different conditions too. So I'm not sure which one actually is the right one to use.
So, anything going on you want to share?
I don't have anything to share, but I have a few questions for Matt. I was looking, or I was thinking about what you did on. You guys can hear me, right?
Yes.
Oh, okay. Yeah, this is being sure. I was looking at what Matt had demoed a few weeks ago at the ROSAG Tuesday meetings, where he was posting paths onto on the simulation. Do you recall that, Matt?
Posting the path in the simulator.
Yes.
Yep.
So I was looking at the path publisher branch, and I came across the Python script that you wrote about that. I wasn't able to figure out how how do the points. So you're inputting a text file called generated points in there, and let me see if I can share the screen here. That will make more sense.
I can pull it up and walk through it.
Can you see?
Yes, we can see.
Okay. Here. Paths. And this file. Can you explain what these numbers mean?
Yes, and I'll say that this is the wrong format. I have since learned that it needs to be in a YAML format in the poses. But what these numbers are, we were playing around with. The very first number is the X. The next number is Y. And then the third number is your heading or yaw. And then the fourth number is speed.
Okay. Yeah, that makes more sense now. Thanks. I was wondering how you were doing that, because I know this. I'm sorry, not this. Here, I know you were doing something with poses. I wasn't able to figure out. But yeah, thanks. Okay, and
Yeah.
how are you generating these points? Is that, are you using anything on here to generate these points?
So what we did is we used the Dubin's path. So just there's like a pip install Dubin's path, and then you send it your start position, your X, Y, yaw start, and then your X, Y, yaw, finish. And then it'll build a path from one to the other.
Oh, okay. Uh, awesome. Thanks. Uh, yeah, I'm looking at some of these things just to get some knowledge. Uh, I'm also looking at uh, different geometry libraries. Uh, and the thing about computational geometry is, and I've learned this, I don't know if this would be of any use, but I just want to share it because I've learned it and why not. Um, so there's different libraries for computational, for drawing lines and polygons and stuff. Uh, but the issue here is precision because and there's different ways to tackle this precision, which I'm learning right now. Because if you have a point that is a floating point, then you need to define up to what precision you need to you need that point on the computer or on the virtual plane. Uh, the few libraries that I've looked at is one of them is the Boost library. Uh, Intel worked on this. Uh, Let me just pull it up here real quick. Uh, okay. Yeah, so I looked at this one, but how this library, I'll share a link. How this one tackles with precision is that they don't allow floating points at all. So it is a really robust library. They've done great work with it, but you can't really use it if you want to use GPS coordinates or local coordinates in ROS or UTM. So this is ruled out, and then the other one is CJA, computational graphics. Uh,
Is this in reference to path planning or area coverage?
yes, coverage basically, but this is what I've been looking at. This provides a lot of algorithms to do stuff predefined. The other one is Geos, but I've found that this one is not as well documented as I don't know how to pronounce it, CJAL. Uh, but yeah, this one has nice, it provides a lot of algorithms and structures. It also has support for other data structures that you might want to use for path planning. But yeah, this is what I'm looking at these days, and uh, yeah, trying to understand precision. there's there's a lot of things with computational geometry. Uh, it's pretty cool, but it's also challenging. So yeah, uh, yeah. Thanks for sharing the information about the ROS package.
I'm still working on that. It's just trying to understand how to build the path and follow the path. I was out driving a path yesterday using the TED planner, and out of the 100 or so configurations, there's one that controls how much force you want to put on your how quickly you want to turn left or right acceleration, the theta, your acceleration theta. And mine was set a little bit too high, and it actually sheared off the roll pin connector onto my lawn tractor.
Oh no.
So Go ahead.
You, at least previously, I don't know if you still do, there was the steer power setting or something. You had it at 55.
Yeah, 50. I think I'm at 50. Yeah, 50. Yeah, like 1/5 of the power from the Citron controller. But
What did this damage? What was the power setting?
no, it's still limited at 50. But I think it was like the left to right motion or how quickly it shifts from one to the other. But it's still, the motor controller is still only driving at 1/5 power.
I don't think I'm understanding how that amount of torque got applied.
Yeah, I don't know. I don't know exactly either. There's in the configuration file for the TEB planner, there's an acceleration theta, and that was set to 2.5, and I actually backed that all the way down to 0.115 or 0.25, and it drives a little bit better.
I mean, that looks catastrophic.
Well, it's though you get two of them for $1, and they're pretty easy to slide in and out. Obviously, you don't want it to break, but
Oh, it was only the pin that broke, it didn't destroy your shaft or anything.
yeah, no, I've got it. I just have a hole drilled through the shaft and through the collar, and then I have a roll pin just stuck in there. And then so it twists it off. Kind of the thought was there is to put a shear pin on that in case I caught a wheel on something to break it off. So I guess in one sense it's
on the motor. How is what size fuse do you have?
Yeah, it's another interesting thing. I have a 15 amp fuse on that, and the motor's rated for 60 amps, and I've never blown the 15 amp fuse. So.
And so, wow, so less than 15 amps sheared that pin.
Yeah. Yep.
Powerful enough motor, huh?
Powerful.
It's also possible that just over time you're just putting stress on that pin, so it wasn't necessarily anything you did right now. It's just that over time that pin is just getting bent a little bit back and forth. It just now decided to quit, or you put a little extra stress on it and it quit. So you might keep an eye on that and see if just normal driving around with your lower parameters, keep an eye on that pin and see if it is going bad on you anyway.
That's a good point. I don't exactly know when it got stressed, but I've been out playing around. Now that TEB planner is maybe a little too difficult for me to figure out. I can get it working on simulation, but when I get out on the real robot, I run into these situations where it gets into oscillations and then says it can't find the path and can't find the location. Even though I'm like lined up directly on the path that I want to follow, it will say, oh, no, can't find a solution, So yesterday I switched over to, Sam found this one. It's a Larix Pure Pursuit. And it literally has like maybe 4 or 5 parameters. Pretty simple, like how fast do you want to drive, how fast you want to turn left and right, what's your look ahead, It's like I can deal with those things. And it's pretty neat. It will drive, and it's kind of outside of the planner. It's not a local planner. Basically, on that path publisher that Soen was showing, you just publish the path that you want to follow, and then this one reads in that path and then just drives it. So we don't get the advantage of having the obstacle layers and the social layers of the nav stack for that type of safety. But maybe this is a simpler way for us to start out. It runs, it's robust, you can just do it over and over again, and it's really easy to configure. There are some things that we could do to make it easier to configure is to put some of those parameters into the dynamic reconfigure, so we can just sit there and dial it. And right now they're in a YAML file, so you have to stop, edit it, and then restart it. But it's pretty quick, and it'll drive it. It'll drive your robot there around.
So, and anything else from your side?
Oh no, that's all. Just learning more stuff.
Matt, anything else?
More fun. You want to see today's project? Oh, can't show that. Nope. Anyway, it's the Nano. But my cable's really short, so I can't show it.
Did it just break apart? Is that what?
No, but I'm always nervous with these little embedded boards to touch it and to move it. Like once it's up and running, I just, okay, fine, it powers up. And this one is like really sensitive on the amount of power it needs. A really good whatever. If you underpower it or try to drive it from your USB port, it won't boot up.
And what are you going to use the Nano board for?
I am right now working on.
Are these the ultrasonic sensors?
No. This is this is the Logitech C9.
Looks like a 920.
Yes, exactly. So the goal, Chinmay and Kalyan have worked out the pipeline for the weed detection algorithm. We want to take that weed detection model and put that on the Nano and see if we can get that running.
Remind me, the Nano is RPi is a Raspberry product?
It's from NVIDIA. It's like a Raspberry Pi from NVIDIA, but it does AI.
Jeff, anything else on your end?
I don't think so.
And Matt, you're still headed to West Lafayette?
Yep, demo time.
When do you hope to get on the road?
Sunday. I'll arrive Tuesday.
Just to reiterate this, there's a registration link if you haven't looked at it yet.
So when you were a little faint, what were you saying?
There's a registration link for the AgBot challenge. If you haven't noticed it yet, or if you haven't registered, I think they would want you to register. Can you hear me?
Yeah, I registered us at a team, so we have we can go to the dinner on Thursday and Friday and play around.
So do I, since you registered the team, do I need to do anything?
I don't know. It's a good question.
I'm looking at the site. So, and you're on the site, by the way. Did you know that?
Yeah, I logged on to register myself. It's cool.
I'm not sure I see a registration thing.
I posted it on Slack in general, but there's also a register button somewhere.
I was just checking to see. Did you put it in general or lawn tractor?
General, just give me something. I'll share it here on Zoom.
Yep, I just found it.
Not this.
Ooh, that website is freaking out. It is not liking that URL.
Jeff, we can pick you up in Indianapolis. Last minute, I'd like to see your robot. It would be cool to have your robot there. 10-hour drive.
Yeah, it's. I'm just not up to it right now.
Okay. Next year.
Okay, guys. Well, good luck on over the weekend. Matt, drive safely.
Thanks.
Any final comments? If not, everybody have a great weekend.
So.
Okay.